Well, thank you so much for the introduction and for inviting me to this workshop. It's a pleasure to be here. I really enjoyed the previous three presentations, and they created a perfect stage for me to start this conversation on assessing the role of forest biomass production by looking at how markets interact and also the effects on carbon balance. Okay, so why are we looking at bioenergy? I think we had a kind of a clear understanding that bioenergy under integrated assessment model scenarios aiming at reaching temperature targets below the 2 degrees Celsius target, they do rely on bioenergy. And why so? Because they provide two benefits. One, they displace fossil fuels, and the second, when they are combined with CCS, carbon capture and storage, they also remove CO2. Vasily did a very great job in describing all the benefits of using BECCS. Just to give you, again, kind of remind you, a few interesting things is when bioenergy is not available, it's more expensive to meet temperature targets, and in some situations, it's actually not even achievable. The other important thing is if you remember the figure of bioenergy demand, future bioenergy demand under different policy stringencies, the demand is expected to start it slow and then growing faster as we extend the timeline, and also more demand and a faster demand when we shift from the 2 degrees Celsius target to the 1.5. This is important because we are going to explore different demand pathways to try to assess the potential issues behind bioenergy consumption and production. Sorry, this is not responding. So, okay. Potential issue of forest biomass. So now we are narrowing down, we are looking only at biomass produced in forest. And what we are interested in is trying to understand the potential problems associated with this significant amount of biomass production. Why are we expecting some issues? Well, because we need land. We need land to produce to meet this new demand. And what we are interested in is how the demand is going to change land use, and what are these land use changes are going to and how these land use changes are going to affect future carbon balance, particularly carbon sequestered in forests and in timber products. So when we think about changes in land use, the first question is changes relative to what? And this is the first point that I want to emphasize is your counterfactual is going to tell you whether changes are positive or negative, the magnitude, and also the timing. So I will use as a counterfactual a future without bioenergy demand, but I will also look at today's as our counterfactual. So I will look at both of them, and I will show you some interesting insights of how this is a very important element. In order to answer these questions, I'm going to use a global economic model of forest, GTM. I have been working on climate change economics and forests for the last 10 years, and GTM has been a very valuable tool to assess different scenarios. It's a tool, so it's, as Vasily was saying, we are not like telling you how the future will look like, but we are testing different scenarios to give a range of possibilities. And then we can discuss how policy could support one scenario relative to the other or avoid potential damages that our scenarios are showing us are likely to occur. Why do we use GTM to explore these changes? Well, it's a nice tool because it has a lot of different forest-based services and goods included at the same time. They do interact, so there is this trade-off. If I'm planting a tree to sequester more CO2 in the future, I'm not going to harvest that because I will reduce the storage. This is just a very, very simple example of trade-offs. The other thing is that there are market dynamics included in GTM. which means that even if we live in a world without biomass, because we want to avoid these potential issues on land use change, we're still going to consume a forest-based product. So we want to include these market dynamics in our simulation. Another important characteristic of this model is it's forward-looking, which is a good representation of how agents in the world react to expected future prices. So if I'm expect that the price of whatever commodity is going to increase, I'm going to invest more than under a scenario in which the price is declining or stable. And finally, it does include biophysical characteristic of forest, which means you're not planting tropical trees in boreal regions, because GTM is telling you that's not the right place. And it's also taking into account growth rates. So in one area, the growth rate of forest is just different than in another area. Okay, perfect. So the first thing we want to do is to include in this global economic model of forest a set of different biomass demands, because we want to measure these effects on land use and land use change and carbon balance. I'm showing you two very different demand pathways. So on your the yellow ones are what we call fixed demand. So they start at different levels, but they don't change across time. This is very unlikely situation. It's not in line with anything we have seen in any sort of projection, but it's somehow mimicking what we have in life cycle assessment. This is just fixed demand. There is no way I'm going to react to whatever price signal or substitution effects. It's just I'm going to consume this amount of bioenergy any time period from now until the end of the century. The second one, the green lines, are showing you 25 demand scenarios that are more in line with what the integrated assessment models were showing us. So it starts very small and then it grows faster. And why so? It's following the implicit carbon price we include in integrated assessment models when we want to achieve specific temperature levels. So these are the two demand pathways categories that we are including in GTM. We ran the model under 50 scenarios separately, and the goal is to try to understand how these singular demands are going to affect land use and carbon balance. Again, we're talking about changes, so the next thing I want to show you is our counterfactual, which is the future without forest biomass demand. We call it baseline scenario. It's based on the SSP2, so a future that is somehow very similar to what we have right now. So the economy is gonna grow, population is gonna grow, and what we are expecting is an increase in consumption of timber products. So you have at the top, pulpwood, saw timber. So these are the traditional timber products are going to increase from what we are right now, present levels, to 2100. And as the demand increases, the price of both commodities are expected to increase. What are the effects of these changes in the production of timber products from now until the end of the century on land, on forest land in particular? So the second figure here is showing you global forest area. So these are global production values. And here you have global forest area divided by 3 categories. So here you have everything aggregated. And down here, global plantation, what we define as highly intensively managed forest. This is what is defined as global naturally regenerated forest, which is in the middle. So naturally regenerated forests where manage is happening, but the forests are regenerating naturally. And finally, it's what we define as unmanaged forests. And when I say unmanaged, is unmanaged for timber production, but still there is some management going on like any sort that doesn't have to deal with producing and harvesting for timber demand. So what we see is, as we increase in the demand for timber products, there is more managed forest than the original value, both for plantation and a naturally regenerated forest. On the other hand, land competition for other land uses, like cropland and livestock, are going to drive a decline in a managed forest. So when we sum up these three categories, we have this slight reduction in global forest area. So this is our counterfactual. This is what is going to happen if we don't have biomass demand included. Now, the final one, which is interesting, is the carbon balance under this no biomass scenario, and is shown here. So you have a stock of carbon in forest, in global forest, and this is expected to increase just because of all these changes. So it's true that forest land is going to decline, but since there are more managed forests that are on average sequestering more carbon per hectare, what we are going to see is an increase in carbon sequestering forest. And also more timber products here are going to store more carbon in the final products, and this is also included in this extra stock for the future. Now, we start by looking at how these new demands, so now we introduce the demand and we are looking at the delta, the change relative to everything I've been showing you here for the baseline. The first one is effects on land use. So what we're gonna see when we introduce the demand. So you have the green ones are growing demand scenarios. The yellow ones are fixed demand scenarios. So we see that for all of them, there are three different effects on land use. One, we're gonna have more. Let me see if sorry, I wanna show you. Well, on top of here, you have more forest land than the baseline. Down here, you have less and managed forest than the baseline. Those are all changes as a percentage change. So we are talking about, by the end of the century, minus 26 million hectares at the global level. So it's a tiny decline, but still a decline. More managed forests, both naturally regenerated, so the one that is not as highly managed as plantation, and also more plantation. So overall, by combining these, again, three categories into the total forest land, we have more forest land than the baseline. The other question we want to check is, okay, what are the ways in which we can meet this new demand? And these are the three options included in the model. So the model has this global demand included, and is giving us basically the cost-effective composition across regions that could meet the new demand. And there are three ways in which the new demand can be achieved. One is by substituting some traditional timber products to meet the new demand. And it's what you have at the top. So down here on the x-axis, there is forest biomass demand, starting from a very small amount up to 4,000 million cubic meter per year. And here you have the share of this demand sourced by substitution of timber products. Forest residues. So we had in the previous presentation a little discussion on that. Forest residues are a good option to meet the demand, but they are because they are usually cheap and available, but the quantity is usually not enough to meet high demand scenarios. And this is what is happening down here. So you see, as the demand increases, the share coming from forest residues is going down to 20%. On the other hand, when the demand is low, the share of forest residues is particularly high. And finally, this is what many people are worried about, is how much are we harvesting of new forests. So the effect of bioenergy demand is that you are going to plant more trees because just there is a more demand for wood-based products. And now what we're going to see is that new forests will be harvested in order to meet this new demand. And this is going to increase as, again, quantity of biomass grows. The market effects are also important. So we have substitution. Substitution is driving a decline in the quantity available for saw timber and pulpwood. So if on one side, so let me go back to this. So what you have, the red lines are our counterfactual baseline without biomass demand. The figure in the middle are showing you the change in total quantity, where you have both the traditional timber products and bioenergy. So as expected, we just produce more because there is this new demand despite the substitution. And also the price is going to increase. But what is interesting is that we have a very different effect on global average price as we move from a fixed demand to a high demand, growing demand scenario, where the price is going to increase in the later scenario is actually going very high at the beginning, but then declining at the end. And this is because the market doesn't have time to plant more trees in response to the new demand, but there is just this huge substitution that will have a sort of a declining effect on prices in far in the future. And finally, the expected effects of substitution of traditional timber products. So let me move to the final result that I really want to show you. What are the effects of this new demand on forest carbon? So you have the baseline case with a slight increase in stock just because of the increase in demand for timber products. What we have in a case where we introduce the new demand of bioenergy is a very different effect depending on the demand pathways. The green ones are showing that there is a decline in the stock, so there is less carbon sequestered in forest at the beginning, and this is because mainly the substitution effect. There is less carbon stored in market products because of substituting these timber products with forest biomass. But as the timeline is extended, we have forests responding to the price signal and just planting more trees and managing more intensively forest is going to increase the stock of carbon in forest under bioenergy demand scenarios. On the other end, the yellow ones are showing us that the decline in forest carbon stock is going to stay until the end of our analysis. So this is 2080, but even in 2100, it does not recover. And if you want to kind of explore why this is happening, the decomposition of carbon pools is on this side. So you have above ground carbon stored in forest products, the market carbon, so carbon stored in market products, soil carbon slightly increasing, and then slash carbon is actually declining because we are collecting residues to meet the demand. So this snapshot,
Alice,
yes.
Time to conclude.
Yes. Let me say these three things. So what is important is really when we want to assess how bioenergy is affecting land use, the expectation on the demand for bioenergy are extremely important because it's showing you when you have demand growth, which are in line with the integrated assessment model, these are going to increase forest carbon stock in the long term. On the other hand, something that is not very realistic, but it was just a way to show you this, is not going to increase the stock at all. What the carbon pools you are including is also extremely important. If you look only at the carbon in forest down up here, then it's always increasing. But if you look also at market carbon, then you have some trade-offs. And finally, the other extremely important thing is modeling tools are important. A static analysis, like the one we try to mimic with the yellow lines, do not take into account dynamic responses, which are part of reality. So they cannot be ignored. I'm gonna stop here, and if you have questions, I'm happy to take them. Thank you.